Good afternoon, everybody, and welcome to this first interactive webinar of the EUCAT 2020 Symposium, which is co-hosted today by the Ertico Academy Friday webinars. So my name is Stefan Dreher. I'm Senior Manager at Ertico ITS Europe, and I'm also the coordinator of the Arcade Coordination and Support Action, which is organizing the EUCAT Symposium. So the title of today's webinar will be how to support fast innovations through different levels of physical and digital infrastructure measures. We will have, on the next slide, we can see a great panel of speakers that, and I will let them afterwards introduce all themselves before the presentations. On the next slide. So before we start, I would like to say a few words about Ertico, the Academy, and as well the Arcade project and the Symposium. So first, Ertico is a public-private partnership representing 120 partners today from 8 different sectors. So these include mobile network operators, public authorities, research, service providers, suppliers, traffic and transport industry, users, and vehicle manufacturers. And all these stakeholders work together on one common goal, which is to develop smart and support the deployment of smart mobility in general. Among our activities, we are involved in EU-funded projects, but we are as well hosting 8 self-funded platforms. And we are also organizing the ITS Congress when it's happening in Europe, and co-organizing the ITS Congress when it's happening in the other regions, so in the Americas and in Asia. Another activity is the Ertico Academy, which is hosting kindly the webinar today. This is a newer activity by Ertico where we are developing training material based on our expertise from us and from our partners on the different projects we are involved in, but as well from the platforms, and where we provide this training material. So there's already some training material available. So if you would like to learn more about that, please consult the link here at the bottom, ertico.com/academy. So in the next slide, so a few words as well about Arcade. So Arcade is a project that is coordinated by Ertico. It's a coordination and support action funded by the European Commission. It started in 2018 and is about halfway through. But it is building on a long legacy of coordination and support actions on the area of connected automated driving. It started already in July 2013 with the Vehicle Road Automation project, was followed by the CARTRE coordination support action from 2016 to 2018, and now we have Arcade. So we have 23 partners, but we rely a lot as well on all the associated partners. We have more than 50 today, and as well on a large network of stakeholders. So on the next slide, we can see that we have in Arcade 3 main pillars, let's say. So the first pillar is really the stakeholder network. So this includes you as well today as participants to this workshop. It includes all the participants to our regular workshops that we organize across with the industry and also research and public authorities with the different experts. We also involve the projects. So we organize regular project consultation events. And all these partners get together in order to accumulate knowledge, exchange on lessons learned, and identify gaps, challenges, and priorities for the future research and innovation actions. All this content is gathered across 12 thematic areas, which we are working on at the moment. They are very aligned with as well thematic domains that have been established by ERTRAC. And in the end, we feed all this knowledge into a knowledge base. So I really invite you to consult the knowledge base. So we have the link here at the bottom. This is one of the main achievements of Arcade today. You can find there an extensive list. We have more than 200 projects and trial and pilot activities listed today across Europe. They are also searchable according to thematic areas and to specific keywords. And the final objective is that all this knowledge feeds into roadmaps. So we are producing as Arcade a consolidated roadmap, which is updated every year. And it feeds as well into the AirTrack CAD roadmap, but as well it has fed in past to the STRIA roadmap from the European Commission. And we are now as well supporting extensively the CCAM platform, which is currently developing as well the strategic research and innovation agenda for Horizon Europe. So on the next slide. So one of the main, in addition to the workshops, we are also organizing several other networking events. So we are co-organizing with the European Commission every 2 years the UCAD conference. So the last one took place last year in 2019 in Brussels. And in between the 2 years, we also organized the symposium, which is a slightly smaller event, but where we focus really on some more key challenges still remaining to be discussed for the deployment of connected automated driving. This year, the UCAD symposium was planned to take place in Helsinki, together in parallel to the TRA. Unfortunately, because of the cancellation of TRA and as well the current situation, we had to reschedule the symposium online. So what we have decided is we will do a series of webinars. We had initially planned 4 workshops, so we will do 4 different webinars. The first one being today on physical and digital infrastructure. The next one should take place in June, so the date is still to be fixed, probably around mid-June. It will focus on validation of connected and automated vehicles, but as well with a strong focus on human factors and how to bring all these aspects up to consumer testing. Then we have 2 other webinars which we are planning more for the second half of the year. One being on sustainability of transport, so does automated driving support sustainability? And the last one on aligning views on the terminology and common description and methodologies beyond the pilots and FOTs. So this is a very important aspect today. We want to define what are we speaking about when we are exchanging about results or defining methodologies. We need to have common views on terminology and in particular use cases, scenarios. So this still needs to be defined. So we'll please stay tuned and consult regularly or the website of connectedautomatedDriving.eu or join us as associated partner and our mailing lists. So on the next slide. So before now handing over to our moderator, Armin, I would like just to provide a few webinar rules and the process. So the webinar is being recorded. All the slides, the results, and also the recording will be shared afterwards and published on connectedautomatedDriving.eu. We want to have this webinar as close as possible to an interactive workshop, which was the initial plan, because we would like as well to get the feedback from all of you as much as possible and use it as well when we will define the future roadmaps and future priorities. So for that, we have decided to use another tool in parallel to GoToWebinar, which is Slido. So we would like to ask you to, if all the questions that you have, please use Slido so you can open it either on you don't need to install any application for that. You can just connect to the website, www.slido.com, either on a separate tab on your browser or on your mobile phone. There you enter the code. The event is hashtag UCAD 2020. And then you click on the event name to start using it. So please only use Slido to ask questions. We will also use it to have some poll questions in between the presentations. And you will be able to interact through that. So all the questions that you ask during the presentations, we will try to answer them after the presentations. And if you have a question that is for a speaker who already presented in the past, then please indicate the name of the speaker in the questions. So that's it for my introduction. I'm handing over now to Armin Grete from BMW, who will be the moderator for this session. So Armin, the microphone is yours. Thank you.
So thank you very much, Stefan. I'd like to welcome everybody again from my side. My name is Armin Greta. As Stefan already mentioned, I'm working in the BMW Group with a long history of electronics and safety background. And at the moment, I'm technical product manager for regulation of automated driving, but having also some other strategic tasks within the BMW Group. So I'm also having the role to co-chair the AirTruck working group on connected automated driving, and I'm leading the working group on automated driving within the BDA, the German Automotive Association. So, sorry for that. Having said these words, I'd like to go at first, before I go into my, no, sorry, please back. Before I go into the slides of my presentation, I'd like to start a first Slido, Paul, so that you can get used to the tool. And I'd like to ask you in an open question, what is your category of stakeholders, so that we can see how many different stakeholders categories are available in this webinar. This is a nice information, I think, for everybody. So please go ahead, open Slido, and type the best way only one word, so that you can see now these words coming up, and you see how many people are there and where are they from. This is, I think, a quite nice thing to test the tool. And I see it opening and starting. And maybe we can look at the result after my presentation again. And then, no, we can not do that, sorry, because I have also another Slido poll within my presentation, but you see it coming up and it will be documented afterwards in the documentation of the webinar. So now coming to my content, as an initial part, I try to be very general and to introduce many of the aspects which the other speakers will deliver in more details and with more focus on other parts. So I like to give an overview on the whole connection between automated driving and infrastructure. And what we did in the past was delivering the AirTruck CAD roadmap last year. And this had the task to increase the scope to better cover the connected aspect of automation and strengthen the links to infrastructure, and also showing that automation is not a subject of technology coming to everything all the time, but having concrete development paths between. So we want to differentiate between passenger cars, freight vehicles, and urban mobility vehicles. On the next slide, you can already see that infrastructure support levels for automated driving were established in this roadmap. Jacqueline will go deeper into this subject later on in her charts. So you see that there are different levels, and in this case, the area of Graz is an example where you can see how a link between two motorways could be covered by different levels of infrastructure support. I don't want to go into the details here because this is a matter of Jacqueline later on. On the next slide already, you can see that this is a kind of the framework of all these things. How do they link to each other? We have now first regulations out from the Geneva UN processes, which is called Automatic Lane Keeping System Level 3. This is a draft version which hopefully will be approved in September in the next official meeting in Geneva. This defines operational design domains, for example, and the homologation framework is covering the operational domain of vehicles with their designs who drive on roads. So, for example, for the highway use case, the operational domain is defined by having a road with a constructional separation to the oncoming traffic, only an example. But also we have traffic rules, which are typically covered by people driving the car. But when we have level 3 or level 4 vehicles on the road, then there's no driver anymore. So the car has to have obligations to be fulfilled by the vehicle driving strategy at last. and this is defined by the traffic regulation framework. And now we have the link between all of them, which is the IDAT levels, which help the car making, let's say, a driving strategy which is correct, which fulfills all the laws, but also helps the traffic flow. So this is the first aspect of having maybe a link to the fall webinar where we discuss about what is the effect of automation on efficiency and other things. I also don't want to go in the details here. So on the next slide, you already see what is the key challenge now, having talked about the regulation framework and all the surroundings and the new task of the vehicle being the driver. So these are things which really define the technology itself. And this chart is quite complex. I'd like to explain it a bit in more detail. If you look at the axles of these charts, on the horizontal axle, you see the driving speed of the vehicle. And on the y-axis, you see the complexity of traffic scenarios. So if you try to solve the problem of automated driving, let's say it like this, we have to face both challenges at the same time. So it's not a surprise that level 3 will start with quite low speeds and on highways, because this is the most simple use case on the lower left corner of this graph. We would expect to have the speed quite easily being higher and higher by the time. So there's even already a regulatory approach running to exceed the speed up to 130 kph, which is just in preparation by industry and some member states. Or not member states, but countries who are participating in the UNEC process. Saying this, it's clear that highway use cases are completely different than urban use cases. So what we expect is in the first generation of level 3 cars on highways in the 2020s, and even level 4 on highways may be earlier than level 4 in urban areas, because the speed, now having discussed this for many years and having development projects also within the BMW group, but with many others, the industry learns at the moment that the speed is not the challenge for urban scenarios is much bigger than the challenge to get higher speeds. This can be done by better sensors and better perception systems, but on the urban environment, we are not that robust yet. So the next step would then be introducing level 4 as a first generation phase in, starting in the 2020s. It's most likely that this is not already in the next years a robust use case. So we see that the trials on urban environments are running for years and years, and the progress is not as big as some people have expected in the past. The last word I want to say to this graph is, if you want to go to rural roads on the countryside, then it's even a bigger challenge, because you have the quite high speeds of 100 kph, for example, in many countries, and you have all the complexity of city scenarios, maybe not in the density of a city, but all of them are there. We have pedestrians, we have bicycles, we have crossings, and this with the high speed. So this is a kind of no idea when this will be able to be handled perfectly. So we expect rural and countryside use cases much more on a very specific solutions, like on specific roads or for specific use cases in transport and for example, elderly people or something like that. But now coming to the key for this webinar, what are now from a really industry point of view, not so much from the infrastructure side developed, but knowing the developments around autonomous driving in the industry, what are the key enablers in the infrastructure to speed up on the development of automated driving. On the highway side, very clear, the high definition maps have to be updated very frequently. So we talk about minutes or even seconds in the future. And this means that we need a good bandwidth to have these high definition maps always in the car. you can imagine these are kind of clusters of road segments which can be uploaded to the car all the time. So maybe the first solutions in the market will show that a minute-wise update would be enough, but maybe later on it's better to do it on a second basis. Also, digitized variable traffic signs will have a very big impact, and also reliable real-time localized traffic infos. So it's very important for the automated car to understand quite good where the limits may occur, so that the handover to the driver can be done as early as possible, so that there's no risk in the takeover. And this helps a lot for the acceptance and also for the reliability and the performance of the systems. On level 4 in urban areas, I just mentioned this is an even bigger challenge. The challenges are digitized traffic lights and also the real-time localized traffic info with other aspects, which I don't want to go in details because of timing, and we will see many more details on that in the other presentations. On the next slide, we have a Slido question again. So please take your Slido tool again, may it be on the laptop or on the phone. So which digital infrastructure measures do you see coming up? And you have this multiple choice. You can do that, and after my presentation we will look at the results. So on the next slide, I only want to take the picture to explain a bit on the technology of on the vehicle side. In the vehicle infrastructure, let's say, not in the road infrastructure, but the vehicle infrastructure, because perception is nice and planning is nice, but if you don't have a backend which delivers the high definition map and updates and the learned algorithms for the artificial intelligence, then all the car technology alone will not cover the requirements. So it's a good perception system. The car has to plan where to drive. It needs to execute the driving, and everything, the whole circle, needs to be validated by simulation. Also, this as a very short input for the discussion later on. On the next slide, you see already one of the 3 development paths roadmaps, which are published by AirTrack 2019. Maybe not every one of you have seen that yet. I only want to mention that we have a focus here on highway autopilot, maybe including convoy. This is not in the first priority focus, but I expect it to come up quite soon when we see level 3 solutions on the roads. And anyway, it has a synergy with the trucks we will later on see. And then the urban and suburban pilot level 4 solutions will be the matter of research for the next years. Please be aware that these roadmaps look into TRL levels, so technology readiness levels of 7 to 9. This means this is not a primary research, but it's also not a serious development. So it's just the pre-deployment, the pre-development phase, and the application research work which is necessary. As you have seen in my other charts, most of the technological approaches, what needs to be done, what needs to be developed is there. So the idea how it could work in the future is there, but it's a lot of work and a lot of research questions in detail to be solved before it comes to the road and be industrialized, especially. On the next slide, you can also see the freight vehicle development paths. They look like in a similar way, but the use cases for freight transport are slightly different, or definitely a strong difference there. You also see completely other types of vehicles. For example, when it makes much sense for big logistics companies to have driverless robots arranging the truck trailers at the hubs. So, and also hub-to-hub operation could be a very, very interesting use case. So this is again one of the big steps where infrastructure could help a lot, because we will see that there are hub-to-hub, let's say, road nets which are quite small, but if they have a strong infrastructure with a high ISAT level, then there will be much more use cases and very quickly to be established. So this is also a very good chance to speed up on automated truck transport. On my last slide now, we see also the urban mobility vehicle development paths, which are around public rapid transport, personal rapid transport, and shuttles. So I know many people don't like the word of the robo-taxi, but this is kind of easily speaking. So shuttles and smaller cars could be a very, very important change of urban mobility at all, and even solve many of the issues which we have today with the road transport. So I think this is the key solution to make cities more livable and also address all the targets which are set from the political side for this research work which we are executing here in the European Union. So this was it from my side as an input. And now we can look at the poll results, which we had in the middle of my presentation. Okay, so we had 46 participants in this poll, it's just going on again. That's nice. Thank you. So some others will have mentioned also what they see there, and we will collect all this also, and afterwards look at it and refer to it. And you have also the question if you have mentioned others here later on, or just now after my presentation. Okay, these are the direct others, but I think that's enough for the moment. If we go ahead now, it's open to questions, I would say. So please put your questions to the Slido, and we have a back office team to sort it out, and we try to be as good as possible to answer what we can do now, but we are a bit in a hurry, so it's not so much time to answer to them. Yeah, a good question here is about the high definition maps. What I just tried to explain is that it's very important to have big clusters, as big as possible clusters of map in the car represented, so that the time interval, if the connection is lost, can be as big as possible. And at last, it would lead to taking over to the driver. That's why we start with level 3. We will see how it works there, and then we can let's say, do the measures to be reliable enough for level 4. And then we have level 4 passenger cars in the mass market. That's a very good question, and I can't answer it, to be honest. And nobody knows it yet. Many people have tried, but I see many years to come before this will come to the market. You can now discuss if many is 1 or 5 or 10. But it will be not. I don't believe in 1, and I don't believe in 10. But I can't say more on that. Political willingness and financial support by the authorities is a very good point, and it's very clear that this needs to be discussed in the groups where they work on it, like CEDAR, and maybe Jacqueline can come back to that in a minute when she has done her presentation. I would leave it at the moment for that and hand over to Jacqueline Erhardt. She's working with ASFINAG and she can present herself. Thank you very much for the moment. I'll be back for the discussion at the end of the webinar.
Thank you very much, Armin. Good afternoon to everyone. My name is Jacqueline Erhardt. I'm working for ASFINAG, the Austrian motorway operator. In my department of ITS services, I'm the team leader for the cooperative connected and automated driving and also digital infrastructure team. And we are working on physical and digital infrastructure elements, but also services which prepare our highways for autonomous vehicles. Armin teased it already that infrastructure could play quite an interesting role in the whole ecosystem of autonomous driving. From a road operator's point of view, we have to just think about right now about the operational design domains for the new generation of vehicles. So as mentioned before, we will have different levels of automation, but from a road operation point of view and traffic management point of view, we have to really consider what happens if a car or a truck enters our highways, and how will it also exit our highways on a safe and also still an efficient traffic way at the final destination. So for us, it is really important that the automated vehicles will or are able to handle different traffic situations where we have not so many cars on the road, or also in urban highways where we have quite a lot of traffic, and so quite a complex effect on the driving situations, which needs to be handled by the machine or the vehicle itself. So on the next slide, you see what we have in mind. With the next click, you will see that, for example, local roadwork zones, which are not planned so far, I mean, we are planning it, but which are just happening on a daily basis, so where we have to close lanes, might be a situation where a vehicle needs to hand over the driving responsibility to the human driver. Or another example for losing this operational design domain could be quite temporary adverse weather conditions. So by the next click, what we have to consider right now is, do those new generation of vehicles really have the same information, or do they need more information to do their maneuver planning or the drivings? So when we consider it, we have just to assume that a machine just needs a different kind of information which the human driver needs, because the human is adapted to really to evaluate different situations. So here's the question, what kind of infrastructure, but also what kind of digitalized infrastructure elements could be necessary to still have reliant and also safe traffic? And that's why with the next click, we introduced the infrastructure supported automated driving classification, we call it ISAT, where we assume that the infrastructure is there like it is, and the car has to deal with it like it is. But of course, we invest, and we also believe in different kind of digitalized services which may support those vehicles with different levels in taking the right decision, and also plan a little bit in advance and have a smoother handover to the driver. So in my first Slido poll, I want to know from you, what is your opinion about which infrastructure services would enable a seamless automated driving on the motorways or in urban spaces? We would really be interested in your opinion. So I think for the next slide, I will take over the control of the slides. And I hope you can right now see my slides. So what you can see here is the
Jacqueline, we don't see your slide.
Okay, thank you very much. Do you see my slides now?
Yes.
Perfect. Thank you very much. So what you see here is the classification. We have structured the scheme in different classes, like starting with E, where the vehicle needs to really recognize the road geometry and all different information on its own. And we level up till the highest level of automation, where the infrastructure is really having a kind of cooperative mode and supports the vehicle by maneuvering through difficult situations. So I would be curious about the poll result. In what services do you see? And so that we can then right now analyze in where we can just order it in which kind of class. Well, since I'm presenting, I cannot see it, I think. But we will go back to it later. Okay, so for the classification D, I said we will step by step increase our level of digitalized representation of the infrastructure. And for the lowest classification, which has already some digital background, every one of us maybe have it, and I'm quite sure you will maybe have a map service in your car, or you will just have right now a kind of a smartphone which can guide you through the situation. So what we assume could be there in the lowest level is just this information about the road geometry and the static informations on the road, which you can already see on your map provider devices. And that could be a good base for autonomous vehicles to plan accordingly the speed, but also the maneuvers. But of course, it will not be at the latest status, and it will not be in real time. So at the next classification, we would see already that more and more information is available through digital services, not in real time, but at least to be there, like traffic regulations, like information about roadwork zones, so that you have already this content about where should be a roadwork zone on the network, which lane should be closed. Then also, of course, the information of variable message signs, where is right now a limitation of speed, or also from a database knowledge, where are the incidents happening on the network. But of course, it's still not, like Armin said, in real time, but could be sufficient for the first generation to drive safely with this minute-based actual data. But what is more interesting and on a kind of real-time traffic information is to get all those messages, like the incident, that there's a broken vehicle, that there is a roadwork warning or zone right before you, or that there is, due to this traffic management of organizing an incident or a roadwork zone, also limitation of speed. We could have this direct communication in real time to the cars. And that's also why ASFINAG invests in this technology of real-time direct communication to indicate, on the one hand, really road safety relevant informations. On the other hand, and I hope it works for you, is that with this direct communication, you also open, it's a different flavor, but you open another possibility of communicating to cars. We assume that we will have, for the first years, connected cars, automated cars, but also normal vehicles. So the whole orchestration of difficult traffic situations could be a little bit facilitated by sending recommendations for lane changes, for sending information about the distance gap between two cars, so to support really the safe maneuvering of cars in specific traffic situations. So that will not be needed everywhere, but at specific sections of the network that could be relevant. And for the highest level of this classification, we assume even to have in real time the full knowledge about traffic situations and about everything happening on specific parts of the network. So what you can see here is when we just invest a lot in infrastructure and generate a full scope of the traffic situation, we could be able to send over a complete object detection list where we have the car classification, the speed and the heading of the car, and so get out a kind of overall perception from the infrastructure to support the vehicle's perception with this limited sensor distance capabilities. Or we could also automatically detect some broken down vehicles, but which could also be enabled by some kind of direct communication. So to share this thought, it's about that the infrastructure is overall the whole traffic, while the vehicle only sees what it can see with its own detectors and sensors. So by combining both, we would just really increase the vehicle's perception. And that could also lead, if we have really a full equipment of roads, that we could guide vehicles through difficult situations. But I also have to mention that will not work to have a full equipment of infrastructure everywhere. It needs to be still investigated which kind of services are really required to enable a safe and efficient automated driving composition of the full traffic, and of course to identify really the most important parts of the infrastructure where this infrastructure support really has an added value. And of course, it's a matter, like the question before, of financement. That's why it's just in a kind of the scheme was introduced 2 years ago, and now is trying to really have a little bit some spotlights on different services which could enable and facilitate the introduction of automated vehicles on our roads. So to close my short talk, I would be really interested in which services should be further developed within the next year. So what do you see should be the service Europe should work on to facilitate and fasten a little bit the market entrance? And I will hand over the presentation and would appreciate to have a look onto the Slido results. Okay, maybe I go to the questions which you already entered. There I see the first question about do you expect road operators will provide HD map information directly to road users? So far, what I see, I mean, there are first projects ongoing where a kind of layer information is provided, but in a sense of a topology point cloud. So I think will it be a real time? I think it will not be a kind of HD map, but it will be more like some additional layer information. There was another interesting question about again the digital representation of traffic rules, if they are needed as well, and the federation of the NAPs. I mean, there are different flavors of the national access points. So there should be a common discussion. I think the discussion is ongoing about how to really digitalize the traffic rules. So I will answer a last question. There was, to close and then hand over to Thierry, for the ISAT classification, have you identified a relation between the support provided at each level and the allowed behavior of CAFs and the potential CCAM services that can take place? So far, we did not consider to really have a one-to-one relation between the ISAT classification and SAE levels, so levels of automation of vehicles. Because the ISAT classification has different flavors, as you might have seen in my slides, and therefore for this different flavor, it will be difficult to really have a one-to-one representation, but it is definitely interesting to see the potential of CCAM services. But I think the first one, which will be interesting to see, is how the direct communication really has an impact on the traffic itself. And I think we start some kind of deployment in Austria, or some kind, we start a CATS deployment, and we hope to see the first benefits on connected and autonomous vehicles soon. So thank you very much. There are a lot of more questions, and I'm interested about the poll results, but I think my time is over, and I hand back and hope to answer your questions later. Thank you very much.
All right, so, well, I'm going to mention a few things. So my name is Thierry Gauger. I'm the Secretary General of FERL. The adaptation of road infrastructure to the deployment of connected and automated vehicle has been something in the air for a while, also within the umbrella of FERL, which is actually an association of research centers focusing on the road infrastructure research. In the next slide, you'll see that we've been adapting and looking for roadmaps already a long time ago. You can even go to the next slide, starting about 5-6 years ago, trying to move on to the next generation of road, in which one of the main pillars is about automated road. So road which are able to monitor their self conditions, but also support the deployment of automated vehicles. In the next slides, we can also show that this effort which was made on the road has been further, let's say, detailed and further worked with the other mode of transport from of course, the work that was done on the Forever Open Road program, but put forwards to the 4x4 open and integrated transport infrastructure, looking at the SAID, at the road, the rail, the river, and the runways, but also not only at technology side, but also infrastructure aspect, governance, and the shared customers. You'll need to click a few times to go to the next slide, please. In the meanwhile, I can let you know that within Horizon and the CEDAR call, there has been a few projects funded which enable to support this R&D, which were put as a roadmap. We had the chance to organize a workshop on the 3rd of March, probably one of the last physical meetings that has happened before the COVID-19 crisis. In that one, the idea was to, well, invite the running one and the ending projects, starting with the EU ITS platform, where the idea there is to gather national ministry, road authorities, road operators and partners from the private and the public sector of almost all EU states and near neighbor countries. Well, they have, of course, a broad scope, but one of their work package is on the facilitating automated driving, where they look at the roadmaps toward the deployment, but they also have a look, and this is also in the next slide, they also have a look at the socio-economic benefits. So this is a very broad umbrella that well, enables in a way framing some of the step-by-step deployment. Well, this was not the only one. We have already in the next slide, so we had a few presentations already, a few words mentioned earlier by other projects. So I will also probably focus on mostly the coexist. So well, anyway, within the workshop, beside the main framework, what we notice is that within the research done at the moment, some achievement and lesson learned can be already taken from infrastructure simulation or simulation of traffic, including CAVs, which is a very new feature now implemented in traffic modeling. Well, still, there is a big responsibility in this modeling on the modeler to define the assumption, how in a way the vehicle should or will behave. And that's something which is an important warning to address at first. What we noticed in the coexist, where indeed the main work was to build this new modeling integrating CAVs, the driving logics are at the heart of consideration, and clearly, if there is already much research ongoing, there is a high need to clarify and to define very clearly the driving logic, so that the model in a way will represent the reality. The other aspect that we can highlight is that the city's expectation management, in a way, well, they have probably lost a bit the hype around the CAVs, and now we are more in the step of learnings, how to prepare for the planning. Considering that all uncertainty requires a structured way of assessing future scenarios, and that's something that we have tried to do in the coexist framework. Please, the next slide. Well, the other very important probably aspect that we can mention, and this is very crucial for the deployment of automation and also for the automation, let's say the infrastructure ready for readiness. Well, that we have demonstrated in the coexist that more or less all the use case simulation that we've run show a hell scenario at the beginning. So in other words, the introduction of the CAVs will most likely be impacting a lot the traffic in general. So having long traffic delay, longer time, longer distance, with the transition that can also be relatively long. And that's a very important message that we want to bring along, because they will have a lot of impact on especially the owners and operators of infrastructure. Well, inserting CAVs, in other words, in traffic does not necessarily improve efficiency, and this is, well, in a way, another comment that another lesson learned. It depends a lot on the penetration rate and the driving logic. For the penetration rate, we have noticed that, well, we need about 70 to 80% of penetration rate in order to show a positive impact. And of course, for the driving logic as well, we need very advanced, in other words, driving logic that can drive as good as a human or even better than a human, knowing more or less all the conditions around the vehicle. And with this together, high penetration and very advanced driving logic, then this can start generating some gains. And that's something which is really important also to have in mind when this will be starting off. Well, last but not the least, opportunities of modal shift towards integrated public transport with automated shared fleets is also something of very high importance. Of course, getting in mind that the service needs to be affordable if we want to keep a social inclusion, and this has to move indeed from a good feeling to a structured and informed decision making. Well, there's been a number of tools developed enabling the assessment of innovative infrastructure measures. You've seen that already in the previous slide from Jacqueline, and I will also highlight it again later on. But this was also the case in the Coexist, where we can where we show that the measure tested show mobility improvement, mainly for high automation and penetration level. The methods show that should urban road change in the transition towards CCM and how. So this was a big issue, and we also highlighted that how to ensure other modes that are not negatively affected by the introduction of CAVs. Well, in the next slide, we had the Inframix presentation, and well, Jacqueline already highlighted and presented very well. So the idea here is not to do duplication. The Inframix, in a way, in the part of the simulation that Inframix made, they were very similar, or they complement what was said within the Coexist. So in other words, there is a need for a very high penetration and very advanced CAVs on the road. But they also highlighted a very important item, is that there is a need to focus in a way the effort on specific environments or specific use cases before we think about deploying on a large scale. And if we go on the next one slide, part of the very important work that was developed there is about the infrastructure support levels for automated driving that was presented by Jacqueline, and is really one of the important tools that can be definitely supporting the very important decision-making process. Well, in the Coexist, which is in the next slide, this is also something which was highlighted, looking at all possible aspects of deployment, from the policy, infrastructure, planning, capacity building, and traffic management, and highlighting that these outcome and this, let's say, preparation could also be better integrated in the SUMP principle, which is something developed at the high city level planning. Before I conclude, there is in the next slide, part of the workshop. We have actually, you can click several times to have the whole slide filled in. There were two other projects that were presented, which also have a very interesting, bring interesting aspect. The first one is about Staple, where the idea here is to look at existing test site within national road authorities in particular, or operators, or at the private level, and having a look at them. And then the idea is actually to move from the existing one, which are often used in a confidential way, to better integration one within the different aspects, from the NRS to the supplier, and looking at how this test site can be in a way improved to bring the right information at the right time. And the question of data, which is in the next slide, is in the two next slides, or you can click 2 times. You can go in the next one. The question of digitalization is very important aspect. What we could notice is that the cooperation is not very good between the public side and the private side, and even within the public side as well. So the data exchange is very poor and needs to be very much improved. As well as data quality, there's been a proposal to let's say qualify that with a number of criteria, from geographical coverage to predictability. So very important, let's say, aspect which is derived now from the Darizon project. And in the next slide, the importance of the cooperation between the stakeholders. So obviously, beside the confidentiality and the cybersecurity, here there is a need for establishing a good collaboration, which in the next slide is proposed to develop a digital platform, having clear rules about how to make it and how to run it, and definitely in the next slide about its exploitation. So who is doing what, who is gaining what, and that's part of the upcoming result that we will be getting from the Darizon projects. So in conclusion, and you can go to the next slide, the idea of that workshop, and maybe the main conclusion are, let's say, 3 or 4 aspects. The first one is we need to focus on specific environment or use cases to move forward step by step. We need to improve very much driving logics within, of course, the vehicles, but within the simulations, which is really crucial. And maybe the last one is, if we want to go safely, we need to have a no regret investment. So we need to identify the no regret investment to move forward steadily, but step by step. I had questions from the Slido, but I at the end decided not to raise them. But on the other hand, I'm happy now to look at the Slido if there are some ongoing questions to which we could answer. Okay, so there is no question to show, but maybe in the discussion there might be coming further. So in this case, I will hand over to Jaap, who will go in deep presentation.
Thank you, Thierry, for handing over. Hello, everyone. My name is Jaap Vreeswijk. I work at Map Traffic Management in the Netherlands, where I'm a traffic architect working on connected and automated driving. And in my talk today, I am also representing the Trans8 project, a project dealing with transition areas for infrastructure assisted driving. And in this project, we've been examining the ODD from the perspective of transition areas. So next slide, please. So this is an animated slide, which requires a few more clicks. We need to define a number of things. We need to define transition of control, takeover request, and minimum risk maneuver. So here an automated vehicle approaches from the left in automation mode. He issues a takeover request, and if that is successful, the driver takes over. But if it is unsuccessful, so the transition of control fails, the vehicle has to make a minimum risk maneuver. As you can see now, the vehicle in this case stops and doesn't enter the no automated driving zone. Yeah, that was a bit quick, but it's all right. We can move on to the next slide. On managing ODDs. Fortunately, this figure was explained by one of the previous presenters. It shows that an ODD has boundaries and gaps, and therefore transition of control may happen frequently. And when it does, there is the risk of reduced driving performance in case the human takes over, or a minimum risk maneuver in case there is no transition of control when the driver does not respond. And in our project, we took this as a starting point. The vehicle is unable to solve the situation ahead, and then considering the scenario where this happens to several vehicles systematically, which has a considerable effect on traffic flow, traffic safety, and other indicators. Next slide, please. So we started examining situations where this happens, looking at statistics and information available on disengagements of automated vehicles in tests around the globe. And we found some examples that you see illustrated here, but we also found that there is not a lot of evidence available yet that really provides a solid basis for this work. Next slide, please. Meanwhile, as a question in Slido, you can answer this question: what do you expect? What do you expect a ZFV will do in case of a minimum risk maneuver? In the meantime, I would say I can proceed with my presentation. So while we were examining ODD, edge cases, transition areas, reasons for transition of control, we started decomposing the whole ODD theme. And here we've distinguished 7 dimensions that are of importance. Of course, these are the levels of driving automation as defined by SIE, which define the vehicle AD functions and capabilities. The road environment matters, whether there is access to the roads by other road participants, whether there are intersections or not, the behavior of other traffic, the extent to which this is uniform or not, the presence of physical infrastructure measures, and the same for digital infrastructure measures, but also situational and environmental conditions matter a lot. If there is heavy traffic, if there are unplanned events like the roadworks vehicle there, weather conditions, and in the middle you see the vehicle and system operational performance, which is more or less the result of all of this, but also something that we want to achieve. We have certain expectations of how well the vehicle or the system should perform under different operational domains. So in the end, what we are looking for often is a geo-fenced area where we can confine the use of automated vehicles. Next slide, please. So we, in the Translate project, one of our objectives was to develop services for assisting automated driving, and we did that on the basis of functions of the vehicle. So roughly you could distinguish 3. The first is to sense and build environmental awareness, and for that the support provided is to provide relevant information, which is also something related to the ISAT levels presented before. So in this case it could be about digital map data, detected obstacles, regulation information or dynamic regulations. Second level is the ability to plan actions by the vehicle, and here the vehicle can be provided with operational support. So provide an alternative action that the vehicle can execute, such as path information, a driving velocity, a headway, a merge or lane advice. And on the last level, it's more a strategic level as seen from a traffic management perspective, is to arrange favorable conditions that allow the vehicle to perform the action. So that could be routing of traffic, it could be orchestrating traffic flows, orchestrating on what lanes traffic is driving, but also scheduling of transitions of control and minimum risk maneuvers. Next slide, please. So we summarize this in 5 services. The first one being providing vehicle path information, and you see 2 examples of that. The second category is to provide speed, headway, and lane advice, for example, at signalized intersections or at merging areas. The third is to separate traffic, for example, to separate automated vehicles from from manually driven vehicles in case of narrow lanes at roadworks or at weaving sections. The fourth is to guide vehicles to a safe spot in case they have to make a minimum risk maneuver so they don't form an obstacle on the road. And the fifth is to distribute or schedule the location of transitions of control. You don't have to wait until the vehicle enters a no automation zone that could be anticipated upstream. Next slide, please. So on Slido, you can again answer a question: which translate service for infrastructure assisted driving do you consider to be most realistic out of these 5 that I presented? Next slide, please. Over the past year, we did extensive simulation work where we simulated both traffic and communication technology, and we assessed all of these services and the use cases that I mentioned before. This is the number 5, where we distribute the transitions upstream, and you can see the without traffic management case, so that's the before case on the left, and the with traffic management measures on the right. And you can clearly see it makes a big difference in terms of congestion, whether or not this measure is implemented. You can also see in these charts that we varied over various levels of service, different traffic mix. Well, this is a level of service C. We also looked at B and D, and there is a deliverable available which contains a lot of these graphs and is interesting reading material. Next slide, please. So here's another example from this study. This is the off-ramp that is blocked by a queue. There is spillback on the exit. So the vehicle normally will stop on the mainstream lane and wait for a gap. Instead, we advise the vehicle to join the queue and wait on the hard shoulder. And if we implement that measure, you can see a clear benefit on both lanes, as you would also expect with normal traffic, of course, if we do that today. But it makes a big difference implementing a measure like this. Next slide, please. Since we're approaching the end of our project, we are also working on the exploitation activities to see how what we've developed can be implemented and operationalized with relevant stakeholders, for example, road authorities and OEMs. Essentially, what we're doing is linking traffic management with fleet management. So we're linking the world of traffic managers and road authorities with the world of fleet managers and OEMs. And this cooperation is not natural, as we have seen and learned in the past years, but there is a sense of trust that is required. And there is a need of understanding, and especially a need to align measures that are implemented on traffic, on vehicles, on the road. So what we've been working on is the definition of an intermediary service that is a single point of access for both these entities and can interact with traffic through traffic information and traffic measures. An advantage is that this intermediary service can also be applied across road authority borders, including those that do not possess a traffic management center, which is very common in rural areas, smaller cities around the world. Next slide, please. Okay, something happened with the layout here. There are very small letters. I hope you can see them. This intermediary service has a lot to do with remote monitoring and control centers. What we've seen in literature and in pilots recently is that for now and in the foreseeable future, level 4 autonomous mobility applications in mixed traffic, to be safe and comfortable, they rely on a remote supervisory service of some kind. So if you'd like to drive without a steward or a fallback on board, this remote monitoring and control center is essential. And services that this center might perform are listed in the blocks on the screen. So it's about monitoring functional safety, technical surveillance of vehicles on the road, scheduling of vehicle services, vehicle dispatch and routing, support all the sense, plan and act stages of the automated driving systems that I mentioned before. And here obviously the use of vehicle to infrastructure communication and other roadside equipment is needed. The status of the road network, network traffic, roadworks and incidents is a service provided. Information and guidance along specific infrastructure segments, such as bridges, tunnels, merging sections, signalized intersections is another service. Also to facilitate the stakeholder interaction and manage clearance levels, so where automation is allowed and where it is not. And last, to provide first and second line help desk services, but also run escalation protocols in case something goes wrong and other stakeholders need to act. We've observed that, that all of these functions, if they are placed in a control room remotely with an operator present, this also contributes to public acceptance of autonomous vehicles. Next slide, please. What we've been doing at Map Traffic Management as one of the project partners of this project, we've started integrating these remote monitoring and control functionalities in our existing service center where we do traffic management services today. We think that by integrating the different domains in one single service center, so the domains of traffic management, of travel information services, of vehicle monitoring and control in one place adds a lot of value, because there is a lot of commonality between those operational processes and therefore can easily be integrated. Our ambition is to have something that is multi-brand and multi-application and therefore can be applied anywhere. Certification is important. It's a common element in the domain of traffic systems industry, and we believe that an approach like this can also be scalable. Before I close, there are two additional questions. They are on Slido. One question is, what do you expect of remote control? There are 5 options to answer. And the other question is, on remote monitoring and control centers should be owned and operated by. And there you can select one or more stakeholders. That concludes my talk, and thank you for listening. Okay, I see some questions. The first one is a question to everyone. Should the CIVs act selfishly as humans do, entering the network immediately and chose the current shortest route, creating the congestion, or that tactical behavior should also be optimized from a system-wide perspective to avoid congestion on the road network? Well, to answer to that question, what I try to illustrate is that vehicles should become part of the automated vehicles should become part of the transport system. They should become an integrated part of it. And in the same manner as we do today, there is some orchestration of traffic over the traffic network. From a traffic management and road operation perspective, it only makes sense if automated vehicles become an integrated part of that too. The second question here is, did you look into responsibilities? Who will finance the support infrastructures? Who is liable if they fail? No, we didn't look into that in our project, but there are some other projects that did. We could get back to this question in the meeting report, unless one of the other speakers wants to comment. The third question here is what are the trust parameters in case of links between road authorities and OEMs. Yeah, trust in this case is mostly on the exchange of information and the exchange of guidance parameters. So if such information is exchanged, you can also make agreements on the quality of this information. Well, you should agree on what is the minimum quality required in order for road authorities to process OEM and act on OEM data, but also the other way around. Especially when we talk about the classification levels B and A of the ISAT structure. The information should be trusted if vehicles are going to act on the guidance that is provided to them. So that is something needed to be defined. I believe my time is up, and I have to hand over to Jan Elsberger.
So thank you very much, Jaap. So I'm Jan Elsberger from Huawei. I'm responsible for industry and standardization activities related to connected and automated driving. I received a kind invitation from Armin and the organizers of this webinar to give you an update on smart roads in China from an industry landscape and standardization point of view. So this will not be sort of a very technical presentation, but rather bring you up to speed on what is going on in China. So if we go to next slide, please. So in China, sort of related to connected and automated mobility, there's basically three stakeholders from the government point of view. So the NDRC, the National Development and Reform Committee, Ministry of Industrialization and Information Technology, MIIT, and of course also Ministry of Transport. And the overall targets or ambitions from a Chinese point of view does not really differ that much from EU, I would say. So the target is that by 2025, industry ecosystem should be established and all necessary regulations in place. The level 3 market penetration of vehicle fleet should be 30%, and level 4-5 commercially available in selected geographical areas. And the cooperative ITS, 5G cellular V2X, and smart road infrastructure should be well underway along highways and in cities. And then by 2030, level 3 market penetration 70%, and level 4-5 general use along highways. So this is sort of the overall ambition level. So next slide, please. Take some time to here. So this is outlining the sort of overall industry landscape across the three concerned industry sectors, so roadside, automotive, and telecom, and also classified according to policy and regulation, trade lobbying and industry organizations, and technology development and standards organizations. And NDRC is sort of working across all the industry sectors, responsible for overall coordination and the investment project planning and sort of approving investment plans. MIIT is working with regulation for telecom and of course also regulation for the cellular V2X systems. On the road side, we have Ministry of Transport responsible for expressways and class 1 to 4 highways. And then we have Ministry of Housing and Construction, which is responsible for all urban constructions, including urban roads. We also have Energy Bureau, who is responsible for the charging infrastructure for electric vehicle. Ministry of Public Security, responsible for all traffic signage. And the Ministry of Natural Resource, who is responsible for maps and sort of issuing licenses for map providers. Looking at trade lobbying and industry organizations, on the right-hand side, Telecom, IMT 2020, sort of the lobbying organization for 3GPP technologies in China. We also have in the automotive space CAAM, that is the China Association of Automobile Manufacturers. We also have China EV 100, that is a think tank and industry association for the EV industry. On the road side, I think relatively well known internationally is CHTS, China Highway and Transportation Society. It was established already in 1921. I think it's quite present on the international scene. Then we also have ITS China as a lobbying organization, and CTMA as the China Smart Traffic Management Industry Alliance. Then on the technology and standards organization side, Telecom, CCSA, that also includes CELA-V2X standards. Then and also CAICV, which is sort of on the borderline between standards and industry organization, and also on the borderline between telecom and automotive. CAICV stands for China Industry Innovation Alliance for Intelligent and Connected Vehicles, and this is a sort of dedicated working in this area with technical specifications and also sort of lobbying efforts. Then we have SA China in automotive, and then we also have on the roadside CITS, and also quite importantly GTG, that is the highway branch of China Engineering Construction Standardization Association, that is typically issuing all standards for the roadside infrastructure. And then in the bottom of the slide you see sort of the as linkage to the main international organizations. So next slide, please. Sort of looking at the status in China when it comes to smart road infrastructure standardization, and as sort of end of April, a draft standard was issued from JTGT with the title General Technical Specification for Highway Auxiliary Facilities Adapted to Automated Driving. So the scope here is to sort of based on cooperative perception and cooperative maneuvering, outline the system architecture and technology requirements for the roadside equipment and services. So the draft standard includes an overall architecture for the roadside system, also the related mapping requirements, what information shall be included in the maps, positioning requirements, the requirements on the communication system, so latency, bandwidth requirements, etc. It also includes requirements on physical and digital signage for automated vehicles, requirements on the traffic control system, also requirements on the capabilities of the traffic sensing equipment along the roadside, so which type of traffic situations must be detected, and also then sort of general requirements on the roadside compute equipment, so compute capabilities in the edge servers, memory sizes, etc. Also requirements on the power supply and lighting, and then also in the architecture there is sort of a service center, which is sort of the central entity managing these type of services. So the document also outlines the capabilities required from the service center. And then last but not least, there is also security related requirements. So this exists as a draft, and then the intent is that this is now open for comments in China, and the intent is to finalize that by the fourth quarter this year. The work is led by the Research Institute of Highways, the National Highway Research Institute, and a number of companies have been involved, ICT industry, Huawei, Baidu, Alibaba, also a number of navigation companies, and also universities. Then the next plan under discussion, not fully agreed yet, is to also develop a corresponding standard during 2021 which is on smart road levels, which is corresponding to the ISAT concept in Europe, which is going to be done through TC204 in SAC in China. So this is sort of the status on the road infrastructure related standardization. So if we go to the next slide, please. So here is a Slido question from my side. I mean, from my company point of view, we think that a certain level of global alignment is necessary, especially from sort of the vehicle point of view. So I would be curious to learn if there is anybody in the audience that have sort of some clear views on where we should drive this type of standardization. And I'm going to look at sort of the results after this. So it's going to be a good input for further discussions. So next slide, please. Also to outline a little bit about the road infrastructure technology providers in China. So companies that are maybe not so well known in Europe, starting on the cloud service side. So providers of public cloud services and also the services on top of that. We have Alibaba, Tencent, Baidu, of course. Huawei is also a public cloud provider in China. Inspur, DD, that is the logo on the right-hand side. We also have a number of high-precision map companies engaged, so Baidu, Navinfo, AMAP, ENG. On the edge intelligence side, edge servers equipped with AI capabilities, so Huawei, Alibaba, Inspur. And then, of course, on the communication side, we have a number of different companies, so Huawei, Datang, Nebula Link, and also a number of companies providing the chipsets and modules for the vehicle side. Then awareness, sort of sensors, Alua and Hikvision, and Leisuo intelligence system for LiDAR, and also Huawei providing LiDAR and camera technologies. And then also positioning companies like Kongshun and BD Star Navigation. So this is sort of just to give you a little bit information about sort of key companies in the infrastructure side in China. And as you may note, I mean, Huawei is present on quite many of those areas. And since we're also present on the vehicle side with autonomous driving capabilities, we are quite uniquely positioned to have a good insight and understanding of the problems that needs to be solved here. So if you go to the next slide, which is also the last slide. So in China, 2018, no, this is not, can you back, please? Previous one, this one, yeah. So in China, already 2018, framework and legislation for testing of autonomous vehicles on public roads was issued. And by today, 109 test licenses has been issued from different companies, covering 16 cities and highway sections in China. And the main cities is listed here and indicated on the map with green. So Beijing, 59 licenses, Chongqing, Shanghai, Pingtan, which is mostly for commercial vehicles, and also Changsha. And as you can see, some very well recognized European brands also obtained licenses in China and is engaged in the industry activities there. And quite a lot of the results from those different test sites has been used as a basis for the draft standard on the infrastructure side. So this concludes my presentation. So let's see if there are any interesting questions in the Slido tool. So who should own and be accountable for digital infrastructures? To everyone, yeah, I mean, we are sort of a technology provider, so we don't have a strong view on that. I would think that it is the road or city authority that is owning and being accountable for the digital infrastructure. That's my personal opinion. Yes, I mean, to go into details of the draft Chinese standard, I think time will not permit here to sort of start a detailed discussion that we can discuss a little bit if there would be a good venue in Europe to share a little bit more around this. As said, from our point of view, we are very interested in securing global harmonization. And then how the business and hence implementing automated vehicles affected in the context of post-COVID-19 in China. I frankly don't have any understanding of insights into that. That is something that we can try to answer offline. So if that was the last question, then I guess I hand back to Armin. And thank you all for your attention.
Thank you very much, Jan. I'll open a kind of. I know that the time is over, and it's always the same that the time is not enough. But we can continue for the next half hour up to 4 o'clock if you like. So if you like to pose further questions, please don't hesitate to do so. I'd like to summarize what we have heard in these 1.5 hours in a kind of let's say short version, only a few minutes, and then we can come back to questions. And I invite all speakers to show up again with this summary so that everyone can again identify who was talking about what. I started with the OEM perspective, and I'd like to not so officially try to classify all the 5 presentations into a kind of structure, because I would name now myself as an infrastructure user, because when we develop automated vehicles, we will use and need infrastructure for that. So I looked very much at ISAT and ODD in an overview. Maps availability and infrastructure invest were already questions on me. Jacqueline from ASFINAG, again, as an infrastructure provider, explained in detail what ESAT means, and if there's a relation to SAE levels was a very important question on that. I think the real-time traffic management, overall traffic perception, and increasing vehicle perception by infrastructure are key topics of her presentation. Thierry from FERL represents infrastructure research. He mentioned a lot about automation-ready framework to tackle the uncertainties, and especially the transition phase will be a very difficult one. But he also mentioned again the ISAT levels, and the focus should be on specific use cases and no-regret investments. Then Jaap followed as an infrastructure service provider. He looked very much into infrastructure-assisted driving, and transitions for limited ODDs is a very important part, especially when the first cars are on the roads. Also, he mentioned the possibility of traffic management to avoid spillbacks and so traffic jams with the concept of linking fleet management OEMs with road authorities by traffic management. I think this is also a very nice idea. A cross-domain service center could be a very good solution for the future. Last but not least, Jan had his presentation on smart roads in China, and I would say this is a kind of the infrastructure strategy which China just shows in his new approach on regulatory framework for infrastructure for automated driving. So this is, I think, really setting government targets and having this impressive network between government and industry with the target of cooperative perception and smart road levels. This is also very much in line with what we have heard from European side. We understood that there are big players in China like Huawei and others who have a broad spectrum around the technologies which are necessary there. But I also like very much, Jan, that you mentioned at last the global harmonization, which could be really one of the key enablers for all of us to speed up the technology and bring it to life and to the people. So please pose your questions on Slido to whom you want. I would, if there's nobody mentioned, I would take the opportunity to answer all directed to one of the speakers. So if we go back to Slido. Okay, thank you very much. Can we reach level 4 automation without better infrastructure? Well, I'll take the question from myself. I would simply say no. It's depending on the use case. It's clear we can start with use cases which may be able to work with this very limited performance in today's network. But I clearly see that there are big improvements necessary. So I like, again, the idea of no regret investments. And that's what I just tried to mention in my slides when I talked about very dynamic maps, high definition maps, and traffic lights and variable traffic signs being kind of first steps in this direction. If this is nice as an answer. Then we have expectations level 4 passenger cars in the mass market. We talked about that already. That's really a crucial thing which nobody can answer yet, and there are so many uncertainties still in the room, let's say in the world, and we did big approaches from an industry side, OEM industry and supplier industry side, the whole value chain, with the white paper Safety First for Automated Driving, which was issued in July last year. And we are just in the way to a big consortium out of 20 partners around is stepping up to bring out an ISO technical report based on this white paper. It's ISO 4804, which will show what are the architectural needs and all the requirements to deliver a safe automated technology. So this is one of the answers, and you will see that there are many things there which are not yet solved. So we will have a lot of work to do before this comes to the mass market. Who should own and be accountable for digital infrastructures, Jacqueline?
Well, the question is which kind of digital infrastructure. I think in Europe we have many very good initiatives where we just a little bit test with this new ecosystem of roads, of infrastructure providers, and of vehicles. So first we have to identify which data is really necessary and what exactly which kind of data is required, and then to see who is responsible and accountable. It's difficult, but I think we do really good first steps in identifying the needs and requirements of level 3, level 4 cars.
Jaap, do you also want to mention something around that? You had ideas around that, I think, as well.
Yes, my answer would be that the ones owning and operating the digital infrastructure would be responsible. Of course, there's a technology element in there, so the supplier of the technology also has responsibilities, but eventually we're going to use and apply the digital infrastructures to operate traffic and to intervene in traffic. Therefore, the one doing that also has an important responsibility and is accountable.
Thank you very much. I think this is now really a nice answer to this question. Back to Jacqueline, 2 questions for you now, so maybe you could go on.
Well, the first one I tried already to answer, that ISOT is a kind of describing the capability of the infrastructure to provide additional data, like also Jaap has shown it in his presentation. When it comes to higher ISOT levels or higher classification, of course, I mean, the ISOT right now is just a scheme. It's a schematic description that infrastructure has the opportunity or the possibility to provide data to vehicles and also influence the development of automated driving. We have to do it step by step. So a higher class definition would even not be right now the thing which we need to keep on working on a more specified way of describing the services, which we wanted to introduce with this classification scheme.
Could I answer that, please?
Yeah, please go ahead.
Yeah, in a way, it extends the answer that I just gave. Although the ones operating digital infrastructure are accountable, there is still a level of responsibility also at the receiving end. I think that's a good example of a level A infrastructure where there is cooperative driving. So there are operational instructions coming from an external source, then still they should be validated somehow before the vehicle acts on them. And in fact, we have been looking at a higher ISAT level than A, which would be remote control driving. So from a remote control center, you remotely drive the vehicle. And I think the common understanding today is that should not be an option. The vehicle itself is a safety feature, is tested, therefore should be able to execute all its driving functions and can only be instructed or send more detailed missions that eventually should be executed by the vehicle. So that could be a higher level than A, but at the same time, a part of that seems to be ruled out as an option.
I fully agree to what you said. I even would like to add, and thank you for that. The point is at last that, as you mentioned it, the vehicle itself will always be a kind of safety layer in this whole system. So at last, I cannot imagine, to be honest, even if I have seen so many projects already, that there is a solution where the vehicle has no safety responsibility anymore. So maybe it could be the case in the very far future that the remote operation, fully managed vehicle fleet can deliver everything which is necessary so that the vehicle gets to its end, but never ever the full safety performance of what is needed in traffic, especially as long as it's mixed traffic. Okay, are the vehicles ready to receive data about infrastructure conditions and geofence definitions? Standards most used? Well, this is a very broad question, and there are so many around. I can only say BMW is just working in Munich with the local authorities on getting traffic light signals delivered in a safe way. So this is not an easy task, and I can say that we are far away from standards here, but there are many others which are available. And maybe Jan, do you have any insight into that?
No, I think it's on the standard side, it's quite fragmented, and there is no sort of common platform in the industry where these type of topics are discussed, and it probably also shows sort of that there is a lot of technology challenges that has to be solved first before we go into real standardization. That is my take on this.
Thierry, do you have any insights into that from the research point of view?
Well, actually, not much more than what you highlighted. There's a lot of discussion. There is a group actually also led by Sweden on the geofencing in particular, with some, let's say, demonstration development with buses, for instance, but nothing more than that. So very far from being ready for a standard.
Yeah, thank you. I think also this is a matter of we're talking about research a lot now here, but standardization is a key enabler for speeding up the development of automation solutions in the road traffic area. So this, I think, is really one of the key things to be solved in the future. I've seen this question up, the HD maps reliability. We had that in the past between the presentations. So I think this can only be solved by having this kind of layer and let's say store enough data in the car so that you don't have to rely too much. There's one question: if we are building a test bed today for technologies that will be in production in 10 years, what should we prioritize? That's a very good question, really. I think this is exactly what we are just trying, and I like to span here the bow a bit further above, away from this workshop here. I'm also in the drafting group of the CCAM partnership to be established till the end of the year. And in this partnership, we are looking very much into the use cases deeper than we had done this before. The Arcade project, in which framework we are working here and discussing here, just is supporting this as well. And we will look very much into the prioritization of research needs by understanding better what are the key use cases for the next 10 years. So this is exactly one of the core targets and the biggest discussion which we have with the Commission for prioritizing the research money for the next 10 years. It's definitely about urban mobility, and we will hopefully launch a first project understanding that better for the next 2 or 3 years, and then afterwards going deeper into understanding this question. This is really one of the key questions for the next 10 years. Okay, one other question from Roberto Blanco, which is nice. I like that idea. But I like to discuss more with real persons. But okay, that's nice. Level 1 to 5. Okay. Well, okay, this is a kind of formal and systematic question. Jacqueline, do you have some insights on this level 1 to 5 and A to D with the ISAT? Or
The funny story is maybe that at the beginning we had a kind of level 1 to 5 classification, but got some feedback from automotive industry and also other stakeholders that it would make sense to not use the same kind of in fact numbering or naming convention for infrastructure than for vehicles. So that's why we are ended up at the latter classification right now.
Yeah, I think
and it is still very difficult in which maybe what we should always have in mind. I mean, even an SAE level clearance, I mean, could elaborate it better, but it is not clear which functionality for which automation level needs which kind of infrastructure support. So there to find a one-to-one matching might be difficult. But we are working on this standardization or this common agreement in what is a kind of infrastructure support level, what is really needed from a traffic management point of view.
Just discussing this between us, I think it's a good idea to refer this in a chapter of the next AirTruck roadmap to really look deeper into where can we say cut the limits of what are good relations. So maybe it's not a good idea to try a level 4 car on country roads with an ISAT level D. So we can maybe separate some corners and focus on some relations between vehicles and infrastructure levels. So this could be some kind of future content we have to elaborate further. Thierry?
Yeah, just to second what you mentioned, actually, that was also one of the recommendation at the workshop last time. So to try to see the combination between the A and the A, B, C, D, and the 1, 2, 3, 4, 5. So that's really definitely something useful. Yeah.
Jan, did you want to mention something?
No, I think I fully second what Thierry and yourself said on that topic.
So now, being 5 minutes to 4, I'd like to stop here. Any questions which have been mentioned are documented anyway, so we can definitely come back and look into these and try to report as good as possible with the documents established after this webinar. Now I'd like to give famous last words to every one of you, maybe in the order, the opposite of the presentation. So Jan, if you would like to start with the famous last word here.
Yeah, I don't know exactly what this tradition with famous last words is. This is the first time I'm attending this type of event, but it was very interesting for me and very good questions. And again, I mean, we are very keen on sort of working on trying to secure global alignment. That's sort of one of the key targets from our company point of view. So that would be my last appeal then, that global alignment is a key word.
Super. Jaap? Jaap, if you like to continue.
Yeah, the screen moved. Yes, well, thank you for the organization of this session and the opportunity to present some of our work and ideas for well, operational elements in the future. Personally, I think this is a fascinating topic. What you touched upon last, the relation between infrastructure, intelligence levels, and different levels of vehicle automation and how they interact. That's simply an interesting topic. Yeah, so let's continue this work on your session next week.
Thank you very much. Thierry?
Yeah, so well, maybe I'd like to say that, or to reiterate this great need for the synergy between the infrastructure progress and then the vehicle. And I think this last suggestion of cross-cutting the infrastructure A, B, C, D, and the let's say level 1 to 5 on the vehicle is a great example of that. The second point is about the no regret investment. I think this is really crucial because we are talking about a lot of money, and here the globalization may play a role, hopefully, but still this will represent a lot of money, so we can't miss in a way the turn. And then I'd like to thank very much everyone, and especially Armin and Stefan for the invitation.
Thank you. Jacqueline, your words.
I can also just underline the importance of working right now together to identify the different worlds of the vehicles industry, also the infrastructure industry, and seeing this challenge and opportunity right now to work together and find a common solution. And I'm really glad that, and thank you to you, that I was allowed to talk here and give my perspective, because I think this webinar now showed how difficult this whole ecosystem is, and how far we already we are in defining solutions. So thank you very much for being here.
Thank you, Jacqueline, very much. I also like to thank everybody of you, and I'm very, very happy that we managed to do this not too late after the planned symposium of the TRA in Helsinki, which couldn't happen due to these circumstances. And I must say it's my first experience doing a webinar like this, and I'm totally happy and completely happy about how this ran, and I think we really managed to do a good job here. Hopefully we get some good feedback from the community which was present. And now I'd like to hand over to Stefan to close. Thank you very much again.
Yes, thank you very much, Armin, and I would also like to join you in thanking all the speakers. I mean, for me, it was also extremely insightful, learned a lot, and as Armin said, I think it will really help us as well in identifying the priorities and where we need to focus next for the actions. which is the main purpose of Arcade, and support the Commission with identifying these priorities. So thank you again to all of you. I've seen we had a very large audience, so I noted up to 150 participants at the peak time from all the regions, not only across Europe, but as well Asia, US, and also Middle East. So thank you to all the attendees for joining us in very early or very late, depending on where you are. And so I would just like to say that because indeed we might not have been able to answer all the questions, or there is still some interest, we propose to let open now the Slido poll and questions. So we will be answering or doing our best to answer the questions until 5 o'clock. So please submit your questions there. And then on the next slide, so I would like to just mention that this was the first webinar from the UCAT Symposium. So our idea was to spread the different webinars across the time until the end of the year as a transition towards the UCAT 2021 conference, which will take place next year. So until then, I hope you will be able as well to join the next webinars we are planning. So the next one will be on validation of connected and automated vehicles around mid-June. And then in fall, we'll have 2 others, one on sustainability of transport and the other one on common descriptions and use cases. So with that, thank you very much again for joining. I wish you still good evening or afternoon or morning, depending on where you are. And thank you. See you soon. Bye-bye. Thanks.